All right, so in section 5.2, what we're interested on is finding the area under a curve. Okay, so that's what we're going to start out with. So I'm just going to give you a function, and then we're going to use several strategies to try to approximate. So that's what we're doing today. We're going to find an approximation. Later on, we're going to bring in the idea of calculus to help you figure out exactly how you can find the area under a curve. Okay, so let's say that you have the problem f of x equals 5 minus x squared, and I am only interested on the interval between 0 and 2. Okay? So, what I'd like you to do is come up with a sketch of what this looks like. It doesn't have to be exact, just a rough sketch of this quadratic just from 0 to 2. So I know that if I'm at 0, I'm going to be at 5. That's going to be my y-intercept, right? So I'm going to say 1, 2, 3, 4, 5. And then if I plug in 2, I would be where? At 1? 2, 1, right? So I'm just going to, for space purposes, I'm going to say this is 1 half. I'm going to say this is 1. I'm going to say this is 3 halves, and I'm going to say that's 2, just so that you guys can see. So at 2, I'm going to be at 1. So about right there. So we know it's a quadratic, so it's going to look something like that. Right? That is all I care about that graph, just from 0 to 2. So I'm not going to graph anything else. Okay? So, again, what I'm interested on is I want to figure out what is this area right here. Okay? Now, without calculus, we're going to be a little limited of what we can do. So what we're going to do is we're going to use your knowledge of geometry. Okay? So to start this off, I'm going to ask you, can you come up with 4 rectangles of equal width? Okay? So we're going to create 4 rectangles with equal width. Okay? So if we're going from 0 to 2 and we're using 4 rectangles, what would that width have to be? 1 half. So all the rectangles would have to have a width of 1 half. Now we're going to have 2 options, and we're going to talk about both of these options. So let me see if I have different colors here. I have yellow. I don't know if you're going to be able to see yellow. Okay. I'm going to be able to make a rectangle right here, and then here, and then here, and then lastly here, right? How I make those rectangles depends on what you want to do. For example, I can go from here and I can go all the way to the curve. When I hit the curve, I'm going to stop and actually make a rectangle. Do you guys see how I have a little bit missing? Yes? But you're going to have to stay consistent. Do you see how I chose to start at 1 half? So in other words, the right-hand side. And that means on the next rectangle, I have to do the same thing. I have to do the right-hand side as well. It's going to be a little bit short. All right? And then I'm going to do the right-hand side, and it's going to be a little bit more. Right? It's starting to show more and more that we're missing. And then lastly, that will be this one, and it's missing actually a lot. Right? However, again, we're doing an approximation. Whatever we get out of this is going to be close to what the area is. Yes? So no calculus so far. Everything we're doing is like, do you know how to make a rectangle? And can you find the area of those rectangles? So let's talk this through. How would I find the area of those rectangles?
Find the y value at 1 half.
Exactly. So we know, for example, the very first rectangle right there, the area is going to be 1 half times f of 1 half. Do you guys understand why? Because that's what's going to give you your height. Because your height is literally where the curve is. Agreed? And then the next one is going to be what? 1 half times f of 1. Are we okay with that? And then the next one's going to be 1 half times f of 3 halves. And then the last one's going to be 1 half times f of 2. Agreed? So now just to make my life a little easier, I can pull out a 1 half, and then I'll have f of 1 half plus f of 1 plus f of 3 halves plus f of 2. Yes? No calculus again. Can you find out f of 1 half, f of 1, f of 3 halves, and f of 2? I sure hope so. Okay, so we're going to say area is equal to 1 half. All right, so what's f of 1 half? Well, if we plug in 1 half into the equation, right, 1 half squared would be 1/4. So what's 5 minus 1/4? 4.75. Cool. Plus, all right, if I plug in 1, what do I get? 4. Plus, all right, if I plug in 3 halves, so 3 halves squared will give you what? 9/4, right? So 9/4 is what as a decimal? 2.25. So 5 minus 2.25 would be 2.75. Okay, plus, now we plug in 2, we get 2 squared, which is 4, and then 5 minus 4 would be 1, okay? All right, so area equals 1/2. So what do we got going on? So we got 4 and 1, that's 5, right? And then 4.75 and 2.75 would give us what? 7.5. So area would equal 1/2 times, okay, so 7.5 and 5 would be 12.5, and I'm going to turn this into a fraction. So 12.5 would be how much? 25 over 2. 25 over 2 times a half would equal to 25 over 4. Agreed? So the area approximately would be 25 over 4 units square, right? So units square. Cool? But it's an underestimation, right? You can clearly see from your drawing that it is less than the actual area. Cool? So then, what if, let's say, you were doing this with a partner, but your partner decided that instead of using the right-hand side of those rectangles, you would use the left-hand side. So that means your partner did this. It started at 0, went up to the curve, and then went towards the right. And then went towards the right. So what do you notice about what your partner has done? It's going to be an overestimation. So you expect that it's going to be a different number. In other words, it's got to be bigger than the area that you found. Okay? So we're going to go ahead and find out what that area is. It's a little hard to see, but I'm using that green marker, so I'm going to just switch back to my black marker. So I'm going to go over here. I'm going to write this down. So area equals. You guys notice how we haven't switched the idea they all have a 1/2? 1/2, so this would be width times height. I'm going to go ahead and use your knowledge, okay? Eventually, I'm going to be able to factor out a 1/2, right? Okay. The first rectangle would have what height? F of what? F of 0. And then the second one would have F of 1/2, F of 1, and then lastly F of 3/2. So we're going to be able to do this again. So 1/2, I mean, we have all these values except for one of them, right? What's F of 0? 5. We already had F of 1/2. F of 1/2 was 4.75, right? So 4.75. And then F of 1 was 4. And then F of 3/2 was 2.75. Are we okay? So then area equals 1/2. And then what do we got? We got 9 plus, we knew earlier that 475 and 275 became 7.5, right? So area equals 1/2. So 9 plus 7.5 would be 16.5, right? How many halves is that? So 33 halves, which means that your area is equal to 33 over 4 units squared. Okay? Now here's what we actually know before we continue. The actual area under the curve is going to be less than 33/4, but greater than 25/4. You guys agree with that? Question for you. Still no calculus. How would you improve or get closer to what the area is? I mean, this is not terrible, but it could be better. How could we get closer? What's that? Find the average of the two. I mean, that's actually more of like a guess in a way, like you're taking the two and then you're averaging out. But we can improve. I mean, it definitely will get us something better. I do agree with that. If you find the average of the two, it is going to give us somewhere in the middle, but it's still going to be kind of a guess, right? Say that what? So we're going to use limits eventually. Make more rectangles. Think about it, right? If 4 rectangles got me that, if I make more rectangles, then those little gaps that were created should start getting smaller and smaller, right? Now, we're not going to do that here in notes. These are just notes. You're going to actually have to do this in practice, like on your homework. Like, I could take this problem and say, do 8 rectangles. The thing about this is that it's just a little time consuming. I just want to make sure that during notes you understand the concept of what we're doing. Okay? You're going to be using rectangles, whatever rectangles the textbook tells you to do, whatever rectangles the AP exam tells you to do. This is guaranteed to be on the AP exam, guys. They like to talk about finding area with rectangles. Cool? Do you have any questions about what we've done thus far? I don't want to make this video super long, so, I mean, there's no reason to do example after example after example. Okay? What I want you to notice is, right now you did two types of rectangles. One of them you used what we call the right endpoint, which was the bottom one. That was the first one. We used the right-hand side. Agreed? And then the second one we used what we call the left endpoint, which is when we started on the left side. So you want to get familiar with that vocabulary. Right endpoint, left endpoint. So based on whatever the instructions tell you to do, that's how you are going to construct your rectangles, and then you can proceed to find the areas. So far, do we feel comfortable with the geometry of this? Because there's really no calculus. We have done absolutely no calculus at all. This has just been algebra and geometry. Okay? All right. There is a third scenario. Let me see if I have a different. Okay. And this one, honestly, not my favorite one, but I think I'm going to have to redraw this because then it's going to get messy. Okay, we're going to use the same problem. Okay, so we're going to have f of x is equal to, what was it, 5 minus x squared, right? So once again, I'm going to sketch this out. So 1, 2, 3, 4, 5, 1/2, 1, 3/2, 2. So we're there, and here's what it looks like, right? Okay, here's what I'm interested in. I still want to use 4 rectangles of equal width, but this time I want you to use midpoint as the height. Okay, so first of all, here's what it means. Okay, we still have our 4 rectangles, right? Like, I'm going to go ahead and do my divisions there, right? There's still a width of 1/2. What it means by midpoints is instead of using the left or the right, you're going to split that in the middle, which in this case is 1/4. You're going to go up to the curve, and right about there, that's where you're going to make your height. So it's going to look like that. It's a little hard to see on that one, so let me show you on this one. So right in the middle of this, that would be about this point right here. So then you're going to make this height right there. So in other words, some of it is going to be on the outside of the curve, and some of it is going to be on the inside of the curve. Cool? The middle of 1 and 1.5 is 1.25. I'm going to go up to the curve. I'm going to make a height right there, and then I'm just going to complete the rectangle. And then lastly, the middle of this would be right here at 0.75. I'm going to make a rectangle here. Why would the midpoint be a better approximation based on what you're observing? Yes, sir. Good. Whatever you're missing here, they're kind of hoping that it's made up with this little extra one. You guys with me? That's the whole idea here with the midpoint. Cool? So if I were to say which one's better between left, right, and midpoint, typically the midpoint is going to get you a better approximation because you've got a little extra, but then you got a little less, but then you got those little extra sides. Cool? All right, so everything from here doesn't change, right? So we want to find this area. We're going to say area is equal. They all have 1/2, right? Okay. Now you got to be careful. So the heights are always going to be the midpoints, right? So this is going to be, the first one's going to be f of what? 1/4, and then the second one would be f of 3/4, and then the fourth one is going to be 5/4, and then the last one would be 7/4. Cool? We're good so far? All right, so this one might get a little uglier just because of the algebra, but I think we got it. Okay, what's 1/4 squared? 1/16, right? Okay, so that's what I told you. It's going to get a little uglier, right? So 1/16. So what's 5 minus 1/16? Let's keep everything in fractions, okay? So 5 times 16 is going to be 80, right? So 80 minus 1 would be 79/16, right? Yes? Are we okay with that first one? Okay. 3/4 square would be what? 9/16, right? So again, 5 is 80, right? So 80 minus 9 would be 71/16. Okay? All right, 5/4 squared is, so 25, right, over 16. So 80 minus 25 is 55. Thank you. Okay? And then lastly, 7/4 would be 49, so that means 31.
Yeah.
Yes? Cool. So then the area, and by the way, I should be doing approximations, not equal. Approximately. So what do we got? 1/2. So we got to add all these numbers. So we got 79 plus 71. That gives us what? 150, right? So 205. So 206. So 236. Yes? 236 over 16. Let's make our life easier. 236 divided by 2 gets us what? 118. So it gives us 118 over 16. Can I keep reducing? Wait, what? Oh, I divided this by 2. I got you. So 118 divided by 16 is what? Or can we reduce? 59 over 8, and I don't think I can do anything after that, right? Cool. So it's going to be approximately 59/8. Questions about midpoint? All right, we've done left endpoint, right endpoint, and midpoint. Yes, sir.
For this, we won't be able to determine like if it's an overround estimate, right?
Correct.
We don't,
Exactly. Good point. We're not going to be able to actually know if this was an overestimation or underestimation because a little bit is on the outside, a little bit is on the inside, so you don't really know what is going to actually end up balancing out to be. Cool? But out of the 3 that we've done, this is going to be your best estimation so far. Yes, sir.
So if this is the best one, why do we need the other three?
It's one of those things, like, I mean, I'm going to go ahead and say this, like about brands, right? Like, if there's always the best brand, why are there other brands? I mean, it's the same thing. It's good to have options. That's really what it means. You know what I'm saying? Really, it becomes very helpful, honestly, the left and the right endpoints when we start bringing the calculus in. It just makes the calculus easier. So, yes, there is some validity to it. Cool? But that is a good question. I'm not going to lie. Okay? All right. We have a 4th way of doing this, which is by the use of trapezoids. Okay? So I'm going to use the exact same problem again, but now we're going to use trapezoids. Cool? All right, so I'm going to go ahead and redraw this again. And again, the whole point here is not really that the function is, I know I'm using the same function over and over again. It's the process. Just making sure that you understand the process, okay? So f of x is equal to 5 minus x squared. That's what we have started with. So we're going to go ahead and draw this again. So we got 1, 2, 3, 4, 5. And 1, 2, 3, 4. So that's 1, that's 2. We were there, and we're about right there, and that's what it looks like, right? We are going to use 4 trapezoids of equal height. And I'll talk about that here in just a second, okay? First, remember a trapezoid looks like this, and especially the trapezoids we're going to be talking about, they're going to look like this. That's what your trapezoids are going to look like, okay? Do you remember how to find the area of a trapezoid? So base 1 plus base 2 divided by 2 times your height. So if you look at this trapezoid, what is going to be representing the height? What connects in this case the bases? And the bases are parallel to each other. So this is, let's say, base 1, that's base 2, and that's your h. You guys with me? Okay. The reason why I'm saying of equal height is because your trapezoids then are going to look like this when you build them. Your height is what you're going to be using at the bottom. You guys with me? Okay. So at this point, if I'm asking you to use 4 trapezoids of equal height, then that means you're going to be doing the same thing that we did. It's going to be 1/2, 1/2, 1/2, right? So here's all you do. This is the cool thing about it. At 1/2, you go up to the curve. At 1, you go up to the curve. At 1.5, you go up to the curve, and then at 2, you go up to the curve. Cool? And now the last step is you actually have to make or build these trapezoids, which means, look, technically you already have the height in the two bases, so you just got to connect those two bases with a diagonal line, all right? So the first trapezoid is going to look something like that. The second trapezoid is going to look something like that. The third trapezoid is going to look something like that. And then the fourth trapezoid is going to look something like that. So we're starting to get better approximations a little bit, right? You guys with me?
But still underestimated.
This is still going to be an underestimation for sure, right? At least the way that it's drawn. At some point, guys, look, I'm keeping it very basic, but the concavity of whatever you're dealing is going to determine whether it's going to be overestimation or underestimation. Right now, I have a concave down. If I had a concave up, then it would be an overestimation. You guys with me? So those are things you're going to consider later on. But for now, let's just make sure, let's take a step at a step, okay? All right, so we got to figure this out, the area for this. So we know that the area is 1/2 base 1 over 2, base 1 plus base 2 over 2 times height, right? What do we know that they're all going to have in common? They're all going to have in common a 1/2 and then the height. Yes? So I'm going to be able to pull out the 1/2 h. Agreed? So we know that the area is approximately this 1/2 h for all of them, right? Okay. Well, let's think this through. Your very first trapezoid, your base 1 is how much? F of 0, right? Yeah, we'll get there. Okay? F of 0. And then the second base would be F of 1/2, right? All right, that's your first trapezoid. Your second trapezoid is what? The first base would be F of 1/2, and then the second base would be F of 1. The third trapezoid is going to be F of 1 and F of 3/2. And then the last one is going to be F of 3/2 and then F of 2. All right, make a quick observation out of all those values. What do you see?
The average rate of change for each section.
What do you mean?
So like, you're taking the height and then of 2 points, and then you're dividing by the distance.
Okay, I got you. I understand what you're saying. I think my question was more like, do you guys notice a pattern on the inside? Everything is repeated except for what? The endpoints. So what you can do is when you're doing these type of problems, guys, you can go ahead and save yourself some time and say, okay, by the way, we do know what h is. I just forgot to put it in here. What was h for us? 1/2. So 1/2 divided by 2 is 1/4. So I'm going to go ahead and put the 1/4. We're going to go ahead and be able to save time, and always you can say it's the endpoint plus 2 times the next whatever value it is, and then plus 2 of the whatever value is next, right, depending on your widths, right, plus 2 of the next, and then lastly you always would have 1 with the endpoint. You guys notice? So the endpoints are always going to be 1. Everything in the middle is always going to be 2. Do you have to know this? No. I mean, if you know it, cool. If you don't, it's okay. You can still get the numbers. Okay? So area is approximately 1/4. F of 0 is 5. We can start out with that. All right? What's F of 2? 1. So we'll start out with the easy ones. Okay, plus 2. What's F of 1/2? So 1/2 squared is 1/4, right? How many fourths is there in 5? 20 fourths. So 20 fourths minus 1/4 is 19/4. I just like to keep things in fractions. You don't have to. That's just me, personally. Okay? Plus 2. What's F of 1? 4, right? Cool. Plus 2. All right. 3/2. So 3/2 would be 9/4, right? So 20 minus 9? 11/4. Are we good so far? There is approximately 1/4. By the way, I do recommend, like, when you take this test, I know you can use a calculator for all this just for speed purposes, but do practice without a calculator because I do give you a non-calculator section of this. So practicing, making sure that you can do, I mean, these are simple operations, just practice. I would hate for you to be using your calculator the entire time and then you get to the test and then you miss it because you did something minimal, okay? All right, so we got 5. So we got 5 here, and then that's 8. And then we got 1 here, right? So we got 6 and 8 would be 14. All right, and over here we got 19 times 2 is?
19/2.
Oh? Yes, 19, I should have done that. Cool. Yeah, 19/2. And then right here I've got 11/2, right? So 19/2 plus 11/2 would be how much? 30/2. 30/2 would be 15. 15 and 14 is 39. So the area is going to be approximately what?
It's 29.
Oh, I'm sorry, 29. Sorry, yes, 29. So that would be 29/4. And that would be as far as I would take it. Cool? All right. Questions about anything we've done so far?
Do you just want us to write underestimation just for practice?
It's up to you right now. I mean, for this one, it is an underestimation. So if I do ask you, is your estimation an under or an overestimation? Just make sure that you can analyze that. For right now, I don't think I'm not going to be asking you about that just yet. Later on, I will. Okay. All right. Questions about how to find area by using left, right, or midpoints of a rectangle? Trapezoids? Okay. So we're going to go ahead and end this video.